we want to continue section 4.2, and so just to quickly go over how to graph a linear equation. And remember, the only thing that we will be graphing are straight lines. And so when you graph a straight line, I will always ask you to label 3 points. Why 3 points? Because if you just pick 2 points, you won't know if you made a mistake. If you graph 3 points, they need to all line up. So if you pick 3 points and they do not line up according to a straight line, then you know you made a mistake. So I will always ask you to label 3 points. So for this section, what we're going to do is basically just pick points and then graph them. Later on, we will use the slope and the y-intercept to graph straight lines, and that is a faster method, but I will show you both methods. And so we also want to make sure we learn how to graph vertical and horizontal lines as well. Let's look at the first example. We have y equal to x plus 3, and so I just have a table here, and what I'm going to do is I will pick 3 x values, substitute them into my equation, and solve for y. And so you want to pick easy values of x. I don't want to pick large numbers. 0 is the best. You always pick 0 because that's easy. Also 1 and -1. So these are always good points to pick because they're easy to work with. Substitute 0, we get 0 plus 3. 0 plus 3 is 3, and so our ordered pair is 0, 3. 0, 3 is a y-intercept. Now if you substitute 1, we have 1 plus 3. That gives me a y value of 4. And if I substitute -1, I have -1 plus 3, which gives me a positive 2. And so I have 3 points. I can essentially have my graph here that I've drawn, and I just label my points. So remember, 0, 3 is a y-intercept. It needs to be on the y-axis. So that would be right here. Then we have 1, 4. So here's 1, and you go up to 4. That would be right here. And then we have -1, -1, 2. So here's -1, and then go up to 2. My 3 points do line up, so I know that this is correct. And so I just graph my line, and make sure you put arrows at the end of your graph. So that's my completed graph. Let's take a look at example B. So for this example, our equation, if I compare example A and B, I notice that for example A, the equation is solved for y. For example B, the equation is not solved for y. Make it a habit to always solve your equation for y. If you have both x and y, always solve for y. And so the first thing I've done here is I've subtracted x from both sides of the equation, which leaves me with a -6y equal to -x plus 3. I always write x first, just so out of habit, so that my equation is in mx plus b form. To solve for y, the next thing we want to do is divide every single term by -6. So when you're doing this, make sure that you're careful with the sign. It makes a big difference. So all of these 3 terms divide by -6. When you divide by -6, the signs will change, so be careful. So right here, what happens is I get y isolated. We have -x over -6, that's positive, and I can write this as 1 over 6x. You can also just write x over 6. It's the same thing. -3 divided by -6 is a -2. Okay, so here's my equation solved for y. Let's make a table, kind of like I did for example A, same idea. I write my equation in the middle, and And then we have our y value right here. And we're going to draw a graph in a second. So let's see. The easiest value for x is always 0. So let's choose 0. Now I can choose whatever number I want for x. You can choose any number you want for x. However, when you have a fraction, we don't want to pick 1, for example, or -1, because if I do that, then I will still have a fraction in my equation. So you want to make sure you pick a value for x so that we eliminate the fraction. So what's a good number for x so that it essentially reduces the 6 in the denominator? A good value for x would be 6 and also -6. You can also choose 12. You could choose -12, and that would be good. 18, -18 are pretty large, but those would work as well. So let's see, substitute 0. We have 1/6 times 0 minus 2. 0 times any number is 0, so this leaves me with -2. Substitute 6. So see what happens when I choose 6 is this is the same as 6 over 1. I can reduce, and we're just left with 1 minus 2, which gives me a -1. Let's try a -6. Okay, so again, reduce. 1 times -1 is, this leaves me with a -1 minus 2, and that gives us a -3. So when you reduce here, remember, you get 1, right? So 1, you end up with 1 minus 2, which gives me -1. I have 3 ordered pairs. Let's graph them. So I'm going to use a ruler really quick to make my graph look a little bit neater. So I want to make sure I have enough space. And, you know, this would be a good way for you to practice your graphing. Your test will contain some graphs, and I will ask you to draw your graph out. So you can always bring a ruler if you wanted to. Hopefully I have enough space here. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, have my arrows, x-axis, y-axis. All right, so let's graph what we have. We have 0, -2. That is your y-intercept located on the y-axis right here. We have 6, -1. So here's 6, and here's -1. And then I have -6, which is all the way here, and -3, which is down here. So we have a point right there. So I have my 3 points, they line up, so I know that this is correct. And then I just connect these with a straight line, and my graph is complete. And then we're done. Let's look at 2 more examples. So what I want you to notice here is that if your equation contains both x and y, then you have a line that will slope in this type of, it could either go up and to the right like these two, or it could also go down and to the left if it had a negative slope. But let me also show you these next 2 examples. So how are these 2 examples different is that if your equation just contains one variable, x or y, then that is how you know that you have either a vertical line or a horizontal line. So if you have both variables, it's just going to be a linear equation that's not vertical and not horizontal. But one variable will tell you if it's vertical or horizontal. So how do I know which one is vertical, which one is horizontal? You might need to memorize this. But basically what happens is if whichever variable you have, that's the variable you're going to solve for. Since I just have x here, I will only solve for x. How do we solve for x? Well, let's subtract 9, both sides. You get negative 4, x equal to negative 9. And then we are going to divide by negative 4. And we will also be graphing this in a moment. So in this case, you do get a fraction, which, you know, we're just going to divide and see what decimal we get. Let's write our answer here. We get x equal to negative over negative gives me a positive 9 over 4. We cannot reduce this. If you were to divide this out, remember, just if I were just to divide this out, we would get a decimal. So let me quickly show you. That gives me 8. We subtract, you get 1. You need to add a decimal point, add a 0. 2 times 4 is 8. Subtract, you get 2. Add another 0. 4 goes into 25 times. So that's our decimal, 2.25. So I'll show you how to estimate that on your graph. So your equation that you have here, let me write it out clearly, is x equals to 2.25. Okay, so this is my equation. So how do I graph this? Well, let me show you. So really quick, here is my ruler again. And just draw my x and y axis. X-axis, y-axis. Let me just put a few markers here. It's a good idea, makes your graph clear. Okay, so if you have x only, it represents a vertical line. So this is something you might need to memorize. If you have x equal to a number, it'll be a vertical line. So we go over to the x-axis. This is 2. This is 3. So 2.25 is between 2 and 3, but closer to 2. So I just estimate the location. Don't have to be perfect, but that's basically the point that I have. And so we draw a vertical line through that point, and that'll represent my graph. So here's my vertical line. Put arrows at the end of it, and then we are essentially done. Let's look at the next example. This one just contains y, so that's the variable we're going to solve for. How do you solve for y? First, subtract 10, both sides. We're left with negative 2y equals negative 10. Of course, divide by negative 2. Change the signs. Y is equal to 5. This is your equation. You probably guessed that if you just have a y and no x, that represents a horizontal line. So make sure you also memorize that, horizontal. Okay, let's draw our x and y coordinates, or axis rather, x and y axis. X, y. All right, so let's see, y equal to 5 will be on the y-axis. All right, so here's 5. 1, 2, 3, 4, right here. Okay, and then of course, horizontal line, so it just goes through 5. And if you were to add, or if you were asked to label 3 ordered pairs, it's pretty easy because look, here's my graph. I can pick any ordered pairs I want. Like you could pick this point, you can pick this point, and just read your ordered pair. So this first point is at negative 2, 5. This point is where? It's at 0, 5. And this point is at 2, x is 2, y is 5. So notice that all of these 3 points will always have a y value of 5, and the x value is the number that changes. And we could do the same thing here. You can pick any 2 points, any 2 more points you want. Like I could pick a point here, I can pick a point here, and we just label them. So the x value for this vertical line is always 2.25, and the y value could be any number. In this case, it's 1. Down here, x value is still 2.25, but the y value is -3. And of course, the number that's on the x-axis is going to be 2.25, and y is 0. So if I ask you to label 3 points for vertical and horizontal line, this is how it works. If you have any questions on any of these examples, please email me so I can explain it. I didn't necessarily go over your questions because I don't know what they are, but please let me know, and I hope these videos are helpful.